You're listening to The Fire Break with Steve Wolf.
Welcome back to The Fire Break. I'm Steve Wolf. As you know, The Fire Break is sponsored by Team Wildfire, developing innovative technology for knocking down fires and dealing with prescribed burns and all the things. You know, you invent a new thing, you don't really know what it's going to do until you put it out there. So next year we'll get it out there and see what it does. I have got with me today Jim Archuleta, who's going to answer some questions for me I have about biomass, because Jim is a biomass utilization consultant. And I'm not sure exactly what that is, but I know that after 27 years with the Forest Service, he probably knows a little bit about what's going on with biomass, certainly as it relates to wood products and things that come out of the forest. Welcome to The Fire Break, Jim. How are you today?
Pretty good, Steve. Thank you.
Absolutely. All right. So tell me, am I way off base? And I say, you know, the secret to the future of climate is use more paper towels.
Well, I think the future of solving a lot of our climate issues, as the forest is concerned, is to utilize more smaller material and less larger material. Reason being is, you know, when I've talked to wildfire experts, especially the fuels managers, they've always mentioned that it was the 1,000-hour fuels or the less than 3-inch diameter material that was the risk of ignition and spread.
Uh-huh.
So if you get rid of, kind of like a campfire, if you don't have any kindling, the logs don't light.
Okay.
So that's kind of my whole tactic in how to address some of this issue is, you know, sure, you can have large logs in the forest, but unless you have enough material to preheat it, and then a continued flame after it's heated, it's probably not going to ignite.
Yeah, that makes sense. So I have a hard time just maintaining my, you know, my quarter-acre lot here. I imagine when you look out at hundreds of thousands of square miles of forest, I'm not sure how you give that assignment, you know, pick up all the tinder. So how do you go about reducing those smaller fuels?
I don't think it would be pick up all the tinder, because I started with the Forest Service as a soil scientist. So
Okay.
some of that material has to be left out there for stand sustainability, site improvement through time, because it's the material that we leave in the forest that creates the soil that builds the condition for the trees that we want. So
Yeah.
if we cut that out, we'll in the future we'll circumvent the future trees. So it's a balance.
Okay. So the right amount. So is there anything behind the idea that we could accelerate the process of little twigs becoming big soil by adding basically, you know, mushroom spores to them? That if we spore seed that area, we could speed up soil production?
Sure. You know, it's all based upon the rate of decomposition. So the faster you can decompose that material, the sooner it's going to become soil. And quite frankly, if you're able to decompose the fine material, it's actually similar, as the effect would be similar to the landscape and fire as it would be to remove it for a product.
Okay.
And you could decompose that material with mushroom spores. You could potentially take biochar and add it to heavy duff layers, and that would actually increase the decomposition too, because that material would hold more moisture. And while you get a lot of moisture from duff already, it doesn't have the nutrient holding capacity that would help it decompose as mushrooms or biochar would help to do.
Okay. So a slurry of biochar and spores might be something we'd want to distribute or try.
I'd be interested in seeing how that would work. Yeah.
Yeah. So tell me about biochar. What is it? How it's made? and what's cool about it?
So biochar is essentially carbonized wood. Uh, Characteristically, it's produced in a low oxygen or a no oxygen or low oxygen environment, and you're essentially removing all of the volatile material off of the carbon structures in the wood. And
Okay.
so you're maximizing the amount of carbon that you have, and that material has an extremely high surface area, and it also has the ability to increase water holding and nutrient holding capacity in the soil. So that's why we're interested in it.
When did you invent biochar?
I did not.
It's
I did not, but it was
been around for a
recognized.
while, hasn't it?
It's been around for a while. There was, I believe, a gentleman out of Cornell University found some instances in the Amazon
Yes.
where folks had been doing this over 1,000 years ago and putting it into place across their, well, they were changing their soil environment in the Amazon. And, you know, if somebody's able to do that over 1,000 years ago without the technology and abilities that we have today, I think we should be looking at it. And the other reason is because they did that in one of the most chemically weathering environments on the face of the earth. So the reason the biochar helped their soils was those soils are extremely leached out.
Okay.
So because of the high water, nutrients flow through or are immediately picked back up into the canopy as they're decomposing on the forest floor.
I
So
see.
the soil itself is not necessarily all that productive. It's the contact between the organic matter in the soil that either pulls it back up into the canopy or leaches it out into the groundwater. By adding the biochar to it, they actually expanded the zone of growth in the soil profile. Some places it's been found tens of feet deep.
Wow.
And like I said, 1,000 years later, it's still working.
So what's the efficiency of making biochar?
Well,
It sounds like
it's
a really an energy intensive process to cook the volatiles out of wood.
if you're yes, it can be. If you're using an external energy source to cook the wood. However, wood has its own energy source. So you could potentially use the energy source of the wood itself after you started the process
Okay.
to feed the system.
Okay.
And quite a few folks have been doing that. And there's fast pyrolysis, there's gasification systems. All of them can make some measure of biochar as they're also producing thermal energy and electrical energy.
So it's like one of those camping stoves that can run on any fuel, right? So as the vapors come off, it's used to heat the fuel source.
Correct.
Okay.
I was at a biochar conference a few years ago, and a guy had brought in he had a gasifier on the back of his truck, and he was running a little genset pack off of the gas coming from that was literally on his tailgate.
Wow.
And it was pretty impressive.
So biochar could really be a useful tool for soil amendment, and it would help hold moisture in the soil, and more moisture would, of course, make a more fire inhibiting environment.
Correct.
As well as provide greater health to the trees and whatever other vegetation. So, what are the obstacles to getting more biochar in the ground in the areas where we need it?
Well, it takes a little bit. It's a little bit more than just. You can stack wood in a correct and appropriate way to maximize the amount of biochar you can produce from a pile, from a burn pile, or you can use some kinds of equipment, such as there's a lot of folks here in Oregon that are using these. It's a fire ring, but it's built in such a way that it's a very low smoke producing process. So it's called the Oregon kiln. There's the big box, which is essentially it's a large rectangular box that's about the size of a trash container or a trash dumpster. And once again, the way it burns and the way it works, it's low smoke, and you're able to produce biochar that way. And then there are the more technical or high-tech processes, such as the work that I've done with the Forest Service on the char boss between the Forest Service and Air Burners Incorporated. That's taking an air curtain incinerator and adapting it to making biochar as a throughput process.
Okay.
So you put wood in the top, it carbonizes the wood in the burn chamber, and then there's a slot at the bottom and agitation in the box, so one side of the box is actually moving. And,
I see.
And that causes the charcoal that's already exfoliating from the wood
Right.
to come off faster, and it falls by gravity. It falls onto a chain belt and is dropped into water and is extinguished, maximizing the amount of charcoal that you can produce.
Okay. And it's pre-wetted.
It can come out. Yeah, well, it's pre-wetted for use, but it's the reason that's done is to extinguish it, because you're in the forest.
Yeah.
You don't want to have embers starting a fire. So by completely extinguishing the biochar that's there, you can potentially either immediately use it or transport it and not worry about, flying embers off the back of your trailer.
Right. So are you, a big biochar fan? Like, do you think that biochar is one of the really important technologies that will, revolutionize the minimization of our burning of the forest? Or do you think this is like one little additional, tool in the arsenal?
I think it's going to be a tool in the arsenal, but it's not going to be a small tool, in my opinion.
Okay.
If just looking at it, or if we're talking about climate change.
Yeah.
Looking at the DACs, the DACs, the direct air capture. You're talking about like that equipment that's in Iceland. That's they're vacuuming CO2 out of the atmosphere, and the intake port is as big as whatever's been engineered.
Okay.
Now, if we look at the vegetation that the biochar folks are turning into carbon, the intake port is as big as the expanse of the vegetation on this planet.
Right.
So which one has more opportunity and lower energy requirements to capture that?
Sure.
And that's the other thing, is that when you capture the CO2 from a direct air capture, you then have to condense it.
Right.
It takes a lot of energy. Then you have to pump it and infrastructure.
I would say there's no future in that technology, but once you dreamed up that it was possible, you had to at least build one to see what it did.
Well, they're building more than one, but
oh goodness,
unfortunately.
All right.
But quite frankly, we should not dismiss any tools. We should just use them in their appropriate and commensurate conditions.
Yes.
So
okay.
I don't want to dismiss anybody's work, but just let's use it appropriately.
Right. But I imagine that to operate that equipment and then condense the CO2, et cetera, like the energy inputs to that probably cause a lot more release of emissions than the amount of CO2 that you're pulling out.
I haven't read the numbers, but it
Okay.
seems like a losing proposition to me.
Yeah. Well, using trees, I would imagine that trees are the most efficient way to get carbon out of the air and turn it into wood.
Well, and we can use, well, that's the thing about using biochar is you can use trees, you can use farm waste, you can use uh, sewage floods, and if
Wow.
you do it at the right temperature with sewage floods, you can eliminate the PFAS, the forever chemicals.
Oh, wow.
So above 1,000 degrees C, you eliminate the PFAS. So then, like in Maine, I guess they had some folks, or a lot of these organic farmers where they've applied biosolids, which is wastewater flood. Now
Okay.
they've lost their businesses essentially because their soils are contaminated.
I see.
But you could potentially avoid that by just
Heating it
temperature
properly.
treating the material at the right temperature and making it biochar.
So would they be doing some type of a soil reclamation project there? A super site fund where they pull off this soil, heat it, kill the PFAS, turn it back into biochar, and then put it back?
I know a couple folks with the EPA, and they're working on different uh, tactics. I'm not exactly sure uh, where they're at with it, but if I do know that they have that process and it's available.
Okay.
I don't think that they would, myself, I wouldn't be removing the soil. I would add to it because I'm a firm believer in my third grade teacher who said the solution to pollution is dilution.
Yes, right.
So the more soil you add to that, the the less the concentration.
Okay. This is assuming that you can get PFASs down to a concentration where they're no longer uh, a health risk.
Correct.
Okay. What are the other biomass sources and purposes, that you study?
Well, I'm working mostly in the forest, uh, so it's I so one of the things that I did is, like I said, I started as a soil scientist with the Forest Service, and in the last 5 years of my career, I worked in the Wood Innovations Program, which is a program that takes uh, a serious look at products like anything from mass timber, wood energy, and biochar were the three topic areas for my program here in the Pacific Northwest. So mass timber is where you can take, uh, let's say, for example, MPP, which is mass plywood panels, and that's taking veneers down to, I believe, a quarter of an inch, uh, making anywhere from 2 inch to 2 foot thick plywood panels that can be 12 foot wide to 40 foot long.
Wow.
So most notably, that material was used to cover the roof of the Portland airport, nine
Oh,
acres of plywood, of very thick plywood. So that's one of the tactics that, just finding ways to utilize the material and either repositioning it into some kind of build product, or finding ways to increase uh, post and poles, or there are other folks in mass timber that are using pole trees. So instead of burning wood, sometimes you can just debark it and scan it and determine where in a building you can use that round timber for either trusses or column support.
okay.
And the reason it's pretty interesting because the round timber itself may have a greater structural integrity than a squared milled piece.
Sure. Okay. That's interesting. so that you just find the right application for the materials that you're working with. So,
Correct.
it's kind of an opposite process of engineering. What are the readily available materials, and how would we build with them, rather than what do we need to build, and let's engineer the supply chain to meet that.
Right. Right. And it's actually been pretty interesting. When I started with the wood innovations group, mass timber was the thing. But this little event happened. The pandemic came
Oh, yeah.
along, and mass timber was focusing predominantly on large office buildings.
Okay.
Well, the pandemic struck, and people didn't want to necessarily build large office buildings anymore. So they started transitioning some of the mass timber work into affordable housing, ADUs, uh, additional dwelling units that you would put like behind your house, to have a grandmother cottage behind your house.
Right.
And this material, initially, it was so costly that it had to be the big building. But now the prices have come down, the technology is improving on how to process it, to the point where they're looking at building a large affordable housing facility here in Portland, at the Port of Portland, that makes these modular units, as opposed to 18-story buildings.
Okay. So when you have mass timber, you can obviously make lumber from that. When you trim off all the little branches and collect the scrub, that's not so great for lumber, but you can make related products with it, using the cell membranes.
The mass timber, as far as smaller diameter stuff goes, it's still the logs. And it depends on the mass timber you're doing. So there's a variety of them. There's CLT, which is cross-laminated timber. There's DLT, dowel laminated timber. NLT, nail laminated timber. Then there's this other one that's made in Utah. It's ICLT, which is interlocking cross-laminated timber, made without adhesive. So
Wow.
it depends on what you're doing, but all of those are probably relying upon a 2x6, as opposed to the MPP, the mass plywood panel, which can utilize down to a 5-inch diameter log.
Okay.
It's not the best place to get your wood for that, but it can use down to that diameter. So that's where mass timber can actually start integrating its way into biomass.
Okay. And what do you do with the smaller stuff? The 2-inch stuff, the baby saplings, even the leaves.
Well, depending upon the forest that you're in, you want to leave some of that material out there. So that's about
Right.
10 to 15 tons to the acre is left out there for stand improvement or stand maintenance. And then the rest of the material could be brought in, and characteristically right now it's burned in piles.
Right.
Dependent upon the logging systems, those piles can be either a 15 by 15 by 15 pile, or you get these large, 200-foot long, 30-foot high monoliths that are associated with whole tree yarding. So that's when you cut down the tree and you don't process it in the unit. You drag it up with tops and branches attached and process it at the landing, making the large pile.
And then you end up with a big Baltimore fire. Huh?
You potentially could. Yeah. So I'm
Yeah.
actually concerned because of the 2022 fires in New Mexico. I don't know if you heard, but the
Sure.
Forest Service
Yeah.
had to recognize that they started a big fire with
Yep.
a hand pile. Now, I believe that the risk of creating a larger and larger pile is just maybe beyond what we need to do, because if we can start the largest wildfire in New Mexico state history with a hand pile, what's the potential of transferring heat from a huge pile into the soil, and it gets released later
Uh-huh.
during the wrong time of the year?
Right.
So that should be a concern.
Absolutely. I mean, I don't know that the size of the pile is related to the size of the fire you can start with it, but it certainly puts the odds against you when you build them that large. What are your
Well,
thoughts on these idea these wood lockers?
the vault.
Yeah, the vault.
Once again, I don't think we should, as far as climate change goes, I don't think we should be taking anything off the table. However, I think they could be done maybe in the right place, and not not relying them. You know, I'm against doing anything bureaucratically and just, we
Yeah.
got to do this practice.
Right.
I'm having come into the Forest Service at the end of the clear cut era. It was pretty obvious that while it's the most efficient processing, it may not be the most environmentally sound.
Okay.
So if we have just one prescription, we're going down the wrong road.
Sure. The right prescription for the right circumstance in the right place.
Correct.
Yeah.
And
Can you just explain to my audience, what the concept of the wood vault is?
so the concept of the wood vault is that if you can get it beneath a certain depth in the soil, it will not decompose.
It being wood, right?
Wood, correct. So the more you put down there, the longer it'll stay. It will potentially it'll also hold moisture too. So as water from above makes it down through and into the vault, it will actually be absorbed into the wood, and over time potentially make its way to aquifers and streams and lakes and rivers. So yeah, it's the same concept as biochar, but the wood, if it ever becomes exposed, is now potentially could start to decompose.
Okay. So the
The
idea is
biochar,
yeah,
when it becomes exposed, it doesn't. It's already decomposed.
right. Okay. And it's made of carbon. It's not going to release its carbon.
Correct. Correct.
Okay.
Even though I'm not a botanist, my reading of the literature is plants don't take up carbon from the soil; they get it from the air.
Yes.
So once it's there, it's largely there.
Yeah. Right. So this, I think of a tree as a solar powered device that takes carbon out of the air and turns it into wood.
Correct.
Right. And it would be hard to imagine people engineering something that does that more efficiently. When you look at something like the wood vault, you have to wonder, for the amount of carbon that you're sequestering in buried trees, how much land are you giving up? How much diesel are you burning to create the holes? Right. And you have to figure out, where the efficiency line is on that.
Well,
Running bulldozers to make giant caverns.
you could take advantage of depressions or the topography and just rework the soil instead of digging a hole and
Yeah.
then covering it. You could take advantage of something in the landfill like like they do with landfills now. They find depressions or concavities and they fill them, and then they cap it. So if you were to vault it like that, yeah, that'd be a lot less work.
And what about using mines, either strip mines where they have to go back in and put 20 feet of soil on top, or coal mines that have been decommissioned, where you have this enormous pit in the ground where you could probably put an awful lot of wood and then bury it?
Potentially you could, but then you're going to be transporting a lot of material.
I see.
So, what's the energy cost there too? Unless you're flinging them with a catapult, I don't think that's too sound of an idea.
Or a train, right?
Or a train, yeah.
Yeah. I think trains are pretty efficient, right, in terms of, cost per ton to transport goods.
Well, yeah, they seem to be. That's how we transport
And
a lot.
I would imagine that if you run a coal mine, you probably have very close access to a rail line.
You're correct.
Right. So
based on my observations, yeah, my limited observations.
Running that train backwards, instead of sending the coal out, you'd be bringing the wood in and burying it.
Right. Or you maybe do both, because you never want to run empty.
Right. So maybe you build biochar at the same time.
Now we're talking.
Okay. All right. We're on to something there, Joe. I knew that, give us a half an hour and we'll have this thing nailed.
We'll solve the problem.
What are the other biomasses that you look at outside timber?
Actually, so I've been kind of looking at the orchard industry.
Okay.
So you drink beer, Steve?
I don't actually, but I understand what it is.
Okay. Well, a lot of folks are so hops are used to brew beer, and people use hop poles made out of lodgepole.
Okay.
And those poles are actually a way now to shade orchards. And the reason that they want to shade orchards is you can go from just using this article from 2018 out of Washington State, about a 48% yield in apples to market, to bring it up to about a 92% yield apple to market, just by having shade and eliminating sun scald or minimizing sun scald.
Wow.
So that's potentially a way to figure out a way to better monetize the lodgepole pine that we have that are, stuck out there 1,000 stems to the acre, which you probably recognize in Colorado.
Sure. So if you shade the trees, you can double the yield, essentially?
Yeah, about 40%, yeah. About a 40% increase. And then I think it's in the Pacific Northwest, it's Oregon, Washington, and parts of Idaho. The orchard industry, just cherries and apples, covers the $2.4 billion a year industry.
Well, that's huge.
So that could be a way to monetize lodgepole.
So then when you double the yield, are you driving the price of these products down?
Potentially.
So your unit economics get worse for the farmers.
But they'll have a lot more available.
Right.
And that's another issue that I think is part of our food insecurity, is our availability of material too, or food.
I'm not disputing that I could probably live on applesauce for a long time.
given
the right amount of cinnamon,
Yeah, there you go.
Yeah. All right. So you're looking at that. What else are you looking at?
And then,
is algae considered a biomass? Is seaweed a biomass?
Well, it is, but I'm really focused on wood because of my background in the forest, and it can be. I do know that there are folks that are actually using that material to actually make fuels.
Okay.
So liquid fuels and solid fuels too. So also biochar.
What are the volatiles that are driven off in the process of creating biochar? Are these volatile gases that could be compressed and used as a fuel source?
They are. So you have, characteristically, you have the biochar, the biogas, and vapor. So
Okay.
when you send the two gases out through a system and put it in through a condenser, your biogas can be used to continue the process and the thermal reaction.
Right.
And then the biochar or the bio vapor can then be put into a condenser and then taken from a vapor to an oil.
Okay.
And that way you condense it into a liquid fuel that you can then, transport like you can diesel or bunker fuel.
And does it have similar properties to diesel?
It has similar properties to bunker fuel. It's a very crude oil.
Okay. Which means what? It's not going to be the
It,
cleanest burning thing out there.
it's not going to be the cleanest burning thing, but if you think about it in the terms of climate change,
Yeah.
now what you're doing is you're cycling carbon in the biosphere as opposed to bringing it out of the lithosphere and then back up into the atmosphere.
Oh, okay. So when we talk about fuels being, dirty when they burn, that's always just going to be a function of oxygenation during the pyrolysis
Correct.
project, right? Okay. Well,
Correct.
you put enough air and agitation in there, and you can get anything to burn cleanly.
Right. I see the benefit of doing that as avoiding bringing more carbon from the geology into the
Yes,
atmosphere.
you're right.
It's not going to burn any. You can burn it a little bit cleaner, but it's still going to be somewhat dirty. But it's not bringing any additional carbon from that storage space into this storage space.
Right. Okay. You're recycling CO2 from the atmosphere back to the atmosphere rather than
Correct.
adding to it with fossil fuels.
Correct.
Okay, that makes a pretty good sense. And what are the names of those volatiles that come up, the vapors and the gases?
There's methane and nitrous oxide, and probably the two bigger ones. I don't necessarily deal in that world. I deal predominantly in getting a lot of folks the feedstock material to do that kind of stuff, or that's my intent.
Okay, all right. And what else do you see as promise out there?
Uh, it's just really there's a lot of other things I think, but from my perspective, those are the ones that I'm really focusing on and trying to help folks capitalize on the most. And as far as as far as climate change goes, when folks were interested in mass timber, everybody would marvel at the big buildings, but there was some literature that started to come out that it's not, as far as climate change goes, the amount of wood that they're using in one big building does not really mean a lot for climate change.
Right.
It's the consistent use of mass timber. So just as it would be the consistent use of mass timber, it's the consistent use of wood energy, or the consistent use of biomass. And that's kind of where my concept of redistributing organic matter across the landscape. So that if we were to think about the forest as an area of surplus organic matter,
Yes.
and then look at if you're going to do an economic equation, if you have a surplus, you're going to have a deficit to move that material. And we do have a deficit. So within the USDA, the Forest Service has surplus organic matter. And also within the USDA, the NRCS has clients, farmers, who have seen deficits in their soil organic matter.
Okay.
So by redistributing the surplus into the deficit, we potentially could have an overall benefit to the USDA and how it spends its money, and maybe some of the soil building activities could be actually a way to fight or prevent wildfire by doing some prevention activities and getting rid of that small material.
I see. Okay. Again, you would have the transportation issues, but it sounds like, those are going to be part of the solution no matter what.
It is, and if you're already having a mill that's so there are some mills such as Prairie Lumber in Mill City, Oregon. They're actually making biochar from their boilers. So is Heartwood Biomass. There are other folks. I believe there's I can't remember the name off the top of my head, but there's some folks in Montana that are similarly doing it. So it's finding these opportunities to capture that material that it's already moved the feedstock. Okay. Now you're hydrating everything you possibly can. And so while there is a limited haul radius that you can use to get that, and then outside of it, that haul radius, we could use the mobile systems where we could take the Char Boss or the Carbonator 5060 or any of these other pieces of equipment that can just make charcoal by doing the fuels reduction. So okay. as they're doing the fuels reduction, they actually are producing biochar too.
Okay. Is this something that's effectively done on site? Let's say you're doing a fuel mitigation program and you're, clearing vegetation. Would you bring your biochar machine up there? And
actually, yeah. If you were to look at the Riverside fire from 2000 on the Mount Hood National Forest, they brought in a Carbonator 5060, and they were all of the roadside stuff that was causing infrastructure problems. They brought to the Carbonator, and they made about a 200-foot long pile of biochar in a windmill, about 10 feet tall.
Wow.
So they can do it. It's just, and then working it out to who's your customer for that biochar.
Okay. So if biochar makes an environment that's good for things to grow in, would you then also not put it in areas where you don't want growth because you're trying to maintain a fire break?
Actually, I would put it in fire break.
You would? Okay. To maintain the moisture?
To increase the moisture. So we did a test on the Diamond Lake Ranger District where I initially was working, and we applied biochar to a pumice soil. And what happened was it increased the water holding capacity of the soil, and we went from soils that are normally drought out after about a month. So that the snow's off in May, and by June you're in drought.
Yeah.
And your grasses are already curing off. So by putting out 2 and 20 tons to the acre biochar, either in the 2 or the 20 tons, we had green grass in August, and it had quit raining according to the RAWS station June, the first week of June. So from June until August the 10th, no rain, and we had green grass, which improved our forage opportunities for big game. It improved our ability to maintain the vegetation that's on site for, keeping back noxious weeds. It increased our live fuel moisture in the most, or the smallest material, which would be our source of ignition in wildfire. So we benefited in wildlife, botany, and fuels management with one application.
Okay, that sounds like a promising win there.
It is.
Excellent.
Now, if we could just do more acres.
Right. Okay. So at this point, it's a scale problem, not a what's the best thing to do problem.
Correct.
Okay. And any insights into what's going to help that scale? What are the monetizations that are going to make scaling worthwhile? Or is
Well,
this something where it's just got to be government funded?
I think it'll be a combination of private investment and government investment. You know, if let's say, for example, that example I pointed out with the USDA, if they could recognize the ability to get rid of that surplus organic matter and apply it to farms, that could benefit, and then that could help really push things. Because we do have farms that have lost, according to the research, over 50% of their inherent soil organic carbon.
Wow.
And soil organic carbon is a subset of soil organic matter. If you increase your soil organic matter by 1%, according to the NRCS, you gain 16,500 gallons of water holding capacity in the soil per acre. So that, looking at a lab that the NRCS uses, that 1% is about 12 tons to the acre of organic matter.
Okay.
So that gives us both a treatment and a prescription of the tonnage that we want to apply to both the forest soils and the farm soils. And yes, I think you mentioned or asked if there are places that you don't want to apply this material, and yes, there are. So that's the other thing that I think is most important about this biochar material is it's not a panacea. You can screw things up.
Sure.
And that means to me that it's real. So
It's potent, right?
What you can do is if you take too much organic matter, or there was a 2008 publication by Wardell out of someplace in Europe, where he found that if you applied the biochar, you could start to decompose the humic layer. So if you have a high organic soil, you probably don't want to apply biochar to it in any heavy loads, because you don't want to decompose the organic matter that's already making up the soil.
I see. Okay.
So, and because of its high water holding capacity, you wouldn't want to put it on the wrong slope, which is already potentially unstable. So you want to look at places where it would be best suited to put it. And the work that the Forest Service had been doing was looking at lands that we had detrimentally impacted, such as abandoned mines, roads that we were rehabilitating, and places where we had compacted the soil for a long term. So these are the cases where we could do the least detrimental impacts, and that's where we were doing a lot of the experimentation first.
I see. And I'm curious, so with the biochar's ability to hold water, do you have to calculate how much water a given acre of a certain type of foliage is going to need, and then not put more biochar down than that, because then you're just holding water that could be well used elsewhere?
It's interesting because so remember when you were a kid and you went to McDonald's and you put your straw in your soda and put your thumb on it, hold it up,
The pipette,
and pulled you, and the water came out.
right?
So that's called capillary action. So that is how the biochar stores water,
Okay.
and it makes it plant available. So it can hold more water than the plants can use. And if that's the case, what happens then is, let's say you put out enough biochar or organic matter to increase your water holding capacity, so that let's say an alfalfa field does not dry out, and it can't use all of the water.
Right.
So there's some that's left in the soil under capillary action. The next year, as the rains come back and start to fill the soil back up to saturation, that water that was then stored is pushed down because of the weight of the new water.
Okay.
And that water keeps going deeper and deeper and deeper every year. So that's the benefit. You're not going to necessarily overwater the plants, but you'll hold enough water to move it down into the profile and send it on its way to aquifers, streams, rivers, and creeks.
Okay. Just wanted to make sure it ends up there, because there's only a finite amount of water on the planet, and we don't want it held in needlessly deep biochar reserves.
Well, there's a lot of water vapor flying around right now. So we
And there'll be more of it. So you actually could use this to dry areas that are getting too much precipitation.
You actually can use this material in theory to dry out wet soil, and you can use it to wet up dry soil at the right loading rates.
So maybe you could mitigate landslides.
I wouldn't necessarily.
No.
I would not be adding, until we know more, I would not add this material to landslide prone areas, because there's no off button. You put this stuff out, it's going to do what it does.
Well, that's a very reserved approach. I appreciate that.
That's what I'm. That's why I've been tried to be extremely cautious with this stuff, because you don't want it to really go bad, because it's on your resume.
Well, what's on your resume is just a source of experience for someone else to do better from. So I would hope that scientists publish everything they do, because it's all just contributing to the body of wisdom from which the next generation of scientists draw. Not so to publish what we think of our mistakes. They're not mistakes. They're just avenues we went down that we probably shouldn't go down again.
That's interesting, because we actually, during the beginnings of my work with biochar, we had a fast pyrolysis demonstration on the Umpqua National Forest, and we brought a bunch of equipment out, and we didn't necessarily have the best results. But we also built a machine pile, and we elevated it. The reason being is we built it in the snow. Snow was about 2 feet deep. So we put two 24-inch logs in parallel, and then built a corduroy deck with other smaller logs, and then just built the pile on top of it. We did that so that we could have that available during the demonstration, to show that that's how you could potentially dry the wood.
Okay.
We had the demonstration, showed people literally 15 minutes or so, showed them that pile. And then the next winter, some hunters burned it as a heating fire. Can't blame them. It's cold up there.
Sure.
But what it did is it deeply charred the two 24-inch logs. It deeply charred them, because now the heat that was created by the pile was no longer conducted into the soil, because we only had the two contacts of the logs, and it created a convection beneath the pile.
Right.
And that deck was largely charcoal when it was done. So just by stacking in an appropriate way, you can make charcoal. And that's one of our mistakes that turned into additional information.
Penicillin yet again, huh? Awesome. Jim, thank you so much for giving me such a great lesson on biomass use. And I definitely see how this is going to become an increasingly important topic of research and application. So thank you so much for sharing that with me.
Hopefully it does. And thank you for having me on.
Absolutely. Our guest, Jim Archuleta, biomass utilization consultant extraordinaire, 27 years of experience in the USDA. Thanks so much for joining me. Thank you all for listening to The Fire Break. I'm Steve Wolf. The Fire Break is sponsored by Team Wildfire. We'll see you at the next one. Take care.